As we continue to look at advanced hypothesis testing using high school student performance data from two high schools, again, we got this data from UCI Machine Learning Repository and brought that data in, made it into the data frames that we need with the data that we will be using. And we will be looking at multiple population mean analysis. So the problem we'll be addressing today is the data that contains multiple schools. So the students from multiple schools. And so we'll be looking at, is there a statistically significant difference in the students' final grades at each school? So the data we'll be using is the schools, which is multiple schools, two schools, GP and MS. And we'll also be looking at the final grades as the dependent variable for both of those schools. So the research question is, are the mean final grades, G3, of each school, GP and MS, equal? So our hypothesis, our null hypothesis is M1 minus M2 equals 0. Our alternative hypothesis is M1 minus M2 does not equal 0. And some of the assumptions in multiple population mean analysis, one is normality. It's commonly assumed that the data is normally distributed. Also, homoscedasticity or equal variances. So we will test for those assumptions with the Shapiro-Wilks test for normality and the Levine's test for homoscedasticity. And we have multiple options. So if the data is normally distributed and have equal variances, we will use the two-sample t-test. If the data is normally distributed but has heteroscedasticity, we'll use Welch's t-test. And if the data is not normally distributed and does not have equal variance, we will use the Mann-Whitney test. So using Python as a tool, again, we can use it to write recommendations for the appropriate test. So checking for normality. If it's not normal, it can give us the message to, or we can create the script for the message to use a non-parametric test. Also, when checking for homoscedasticity, we can do the same thing and have it let us know whether variances are equal or not. And we can use that to determine which test we use. Again, here, two-sample test, Welch's t-test, or the Mann-Whitney test. And we can also use it to interpret the test results of the hypothesis test as well. And we can use it for data visualization using a box plot to visually support the findings of the data. And we can see some of the things that the data visualization in the box plot can tell us is the box spread represents the final grades for each school. We can see the median of the data, the range based on the whiskers, and we can see basically if it looks similar and if there are outliers. So we group the data by school, we check for normality with the Shapiro-Wilks test, and we check for homoscedasticity with the Levine's test. And what we find here is the data is not normally distributed and the variances are not equal. So based on the recommendation above, we will be using the Mann-Whitney test. So as we use the Mann-Whitney test and plot the visualization, what we'll see using it as a tool is the p-value is less than the significance level, which means that the final grades differ significantly between the two schools. So as we look at the distribution of the final grades by school, we see here that they are different. The median of GP is higher than the median of MS. GP has multiple outliers both above and below, and MS has a wider range, and it also has an outlier on the lower end as well. So this is how we're doing comparison of multiple means using the Mann-Whitney test.